Okay, I'm continuing. We'll see how this works. This is for question number 6 on Tuesday. We're listing the factors. So I like to go in order, and we went 1, 2, 4. We know 5 doesn't work. We know 6 doesn't go into 32. We know 7 doesn't work. And what happens is when I hit 7, I know that, that I can go, it's kind of like a U. When I hit 7, I have 8 and it goes in order. And so I know I'm done. I'm done looking for numbers that work. And so then I can list my factors easily. 1, 2, 4, 8, 16, and 32. Okay? That's the best way for me to make sure I don't miss my numbers. Some kids call, they said that the word factor has an R in it, and so it's used the rainbow method. And when you list it, let me list it again here so you can see. They go back and forth. They know that they make a little rainbow, and the outside number goes with the next outside number. And so you can check to make sure that you have a pair. If there's a middle number, that means that it's a square. So let's say for the number 16 example, you would just have 1 4. 4 times 4, you would only write it once. Okay? I think that's the best advice I have, is to just double check yourself with the rainbow, go in order so you don't miss a number. Next, what is the GCF of 12, 20, and 36? Remember I said the sock method, or the factor slide method doesn't always work with the 3 digits. So what I just recommend is listing the factors. So all I do is I write 12, 20, 36, and then I list them out. So I know the factors of 12 is 1, 2, 3, 4, 6, and 12. And I know 20 is 1, 2, 3 doesn't work, 4 works. So 4 times 5, and then 2 times 10, and then 1 times 20. And then 36, I would have 1, I would have 2, it's an even number. I have 3, I have 4. 5 doesn't work, 6 works. Remember 6 times 6, so I'm only going to write it 1 time. And then I'm going to go 4 times 9, 3 times 12, 2 times 18, and 1 times 36. Now, the greatest means which one of these is the biggest. Of course, they all have the 2. They all have a 4. They don't all have a 6. They don't all have a 12. And they don't all have a 3. Which is the biggest number that they both share? I mean, all of them share, excuse me. The number 4. So the GCF is 4. Okay, be very careful. It has to be true for all 3. Okay? Next one, find the GCF of 8 and 20. Use 2 different methods to demonstrate your answer. Well, I'm going to use the one here, just listing it. And then I'm going to go back and use the factor slide, okay? So GCF of 8 and 20, I'm going to list them. One, 2, 4, and 8. That was easy. And I'm going to go back and steal. I'm going to copy what I have up here so I don't create more work for myself. Maybe that's lazy. I like to call it smart. We shall see. Okay, and then which one do they both share? Currently, I think 4 is the best one. I love doing 2 different methods because now I can just double check myself. I'm going to do the factor slide over here, 8 and 20. What can they both be divided by? A prime number, 2. So I have 4 and 10. What can 4 and 10 both be divided by? Again, 2. Can 2 and 5 both be divided by the same number? No, not evenly. So I'm done. I'm going to circle the left-hand side. This is my GCF. I have to multiply it. So what's 2 times 2? 4. So what's my answer here? 4. So I did it correctly. I feel very confident because I did it 2 ways. Okay? Find 2 numbers that have 2, 3, 5 as factors. What other factors do the numbers have in common? Okay? 2 numbers that have these as factors. Okay, well, I'm trying to think. And I think a good one would be 30. What do you guys think? Okay? So 30, because it has 2 times 15. It has 3 times 10, and it has 5 times 6. What else has those same factors? Well, I know 10 doesn't, even though the 2 and the 5, okay? What about 15? 15's not an even number, so that doesn't work. So I know the simple way to answer this is I'm going to double this 30, and I bet 60 will work, okay? So 2 times 30, 3 times 20, and 5 times 12. What other factors do these numbers have in common? What else does 30 and 60 have in common? Well, watch this. And this is not in order, so it bothers me. All right. Well, let me cram it in here. 1 times 30. And then notice here. So look, they both have what? 30 in common, okay? They also have, and I don't know where I can put this, right here. I'm going to cram it. 4 times 15. So notice this, 15. Okay? They both have, let's see, they both have 6, because then you have 6 times 10, okay? So hopefully you found some that they have. Of course, well, I circled the wrong thing. Did you guys catch that? I want to circle the 6 because they both have the 6, but then the 10 also needs to be circled. I was pulling a crazy move there, sorry. Okay? Which of these numbers has the most factors? Which of these have the most factors? Well, let me tell you something. Which one's a prime number? You got that right. 1 times 17, so that looks like a bad answer. Okay, I know that this has 2, 1 times 6 and 2 times 3. And then I have 1 times 25 and 5 times 5. Ooh, I bet it's this one, but I'm going to list it just to prove my point because I like to prove it. I was horrible at science growing up, but for some reason when I come to math, I love to prove my point. I'm very stubborn. Okay, so of course, who has the most factors? 36 is the best answer. Okay? Okay, I'm going to flip the page over. That was Tuesday's homework. Okay, I'm on Wednesday. I'm going to try and pick up the pace, but I doubt I can move faster because I'm kind of a slow book. The greatest common factor of 2 numbers is 3. The 2 numbers are between 35 and 46. The greater number has 2 more factors than the lesser number. What are the 2 numbers? Well, goodness gracious. It's a lot to look at, isn't it? Well, the only way I can think about this is the GCF of the 2 numbers is 3. So, the first thing I'm going to think about is anything that has a factor of 3. So 35 doesn't even have a factor of 3. What about 36? So I'm going to list it. What about 37? Nope. 38? Nope. 39? Yeah. What about 40? No. 41? No. 42? Yes. 43? 44? 45? Sure does. Okay. So those are my 4 numbers that have a, the GCF of the 2 numbers is 3. So they both have a factor of 3. Okay? Now, The greater number has 2 more factors than the lesser number. Okay, well, let me list my factors. I'm going to go as quick as I can, but it's going to take some time. 2 times 18, 3 times 12, 4 times 9, 1 times 39, 2, 3 times 13, I was checking something on the other page. Sorry, guys. Am I making anyone motion sickness? Have motion sickness? I hope not. 1 times 42, 2 times 21, 3 times 14, 4, 5, 6 times 7. That's it. And then I have 1 times 45, 3 times 15, 4, 5 times 9. Okay, so the greater number, the larger one, has 2 more factors. Okay, well, if this one's larger, does it have 2 more factors than 36? No. Does this one have 2 more factors than 39? Yes. Does this one? No. So I think it's these two. Okay, now the other part that I need to go back to is that it has a GCF of 3. I know it has a factor of 3, but is the GCF still 3? And it says yes. So what's my answer? 39 and 42. Yay, I did it. Okay. List at least 5 facts about the number 455. Okay, it is a odd number. Making it, class, do you think it is prime or composite? You're right, it's composite. It is divisible by, yes, 5, because it ends in a 5, right? Okay. What else? It is a multiple of 5, right? Okay. What else can we say about it? I'm trying to think of something else about a factor. I don't know. I'm trying to think of like a factor one. That's kind of challenging. Okay. You know what? I'm going to have to come back to that one because I want to think of something cool, but I don't, my brain's kind of mush. I can't think of a 5th one. It's an odd number. It's composite. It is divisible by 5. And it has multiples. It's a multiple of 5. I'll have to come back. I have 4. Oops. What is the LCM of 12, 8, and 3? Show your reasoning. Okay, so I'm still, remember, I don't want to do this factor slide with 3 numbers. It makes me extremely nervous. Least common multiple. Don't forget, I want to look at multiple, and I'm going to skip count. I'm going to multiply. So I have 12, 24, and then I have 36. I'm going to stop because I know 8 and 3 are really small, so I'm going to just go with that. 16, 24, 6, 9, 12. Notice I have the 12 and 12, but not here. And then I have 15, and then I have 18, and then I have 21, and then I have 24. Notice the least common multiple the first time they all meet up is 24. LCM is 24. Okay? Solve using the list method. So listing, just like I did up here, okay? So I have 6, 12, 18. I'm going to stop there because I know that it goes 9, 18. I don't want to create work for myself if I don't have to. Again, I might be lazy, but if I've shown my work and I've done my best, I'm going to trust my gut that I've done the right thing, and I want to stop so I can spend some time on other problems that take maybe a little more brain power. Same thing with 12 and 24. I know that if I skip count, 24 comes next, so I don't really have to do much for this problem. Really easy. How many multiples should you list when trying to figure out the LCM? Well, I kind of explained that. You know, a good response would be enough so that you show your work, but don't write something cheesy like, whenever I have the answer in my, I don't know. But again, just enough so that I can see that I've not done anything and I can see my work. I don't know. Solve the problems in 14 using another method. Well, again, I could do the LCM with these, with the sock method or the factor slide. You stick 6 and 9 in here, and I'm going to divide them both by 3. That's a prime number. Oops, am I focused on the right thing? And I have 2 and 3. So then, remember the LCM, you have to multiply all of them. So what is 3 times 2 times 3? Well, that's 6, and then you get 18. Yay! And then when I have 12 and 24, it sounds silly for me to even do this, doesn't it? But I'm going to do it anyway. I'm going to divide this by 3, 4, and 8. Could I have done it with 2? Sure. Because you're going to notice here, I'm going to do it with 2, which you get 2 and 4. And then I'm going to do it again, 2. 1 and 2. Can I do anything with the 1 and the 2? No. So I'm going to find the the LCM again. So you're going to notice I'm going to take all of this, right? So what is 3 times 2? Yes, it's going to be 6 times 2 is 12, times 1, 12, times 2, 24. And that's what I got for the least common multiple up there, okay? Hey, I need to go back. I would like you guys to write a response here, but because we talked about it, I just skipped that over. But definitely, you know, how can you try to find the LCM? How many multiples should you list out? I would write just enough so that I can see my work and see where it meets up. If you don't see a number that meets up, you haven't gone far enough, okay? Going on to Thursday, problem number 16, which set lists all the factors of 12? Well, guess what I do? Close your eyes, cover the answers up. I hate multiple choice because I never pick the right one. So you just want to cover it up like that. What I do is off to the side, I'm going to write 12. And I do 1 times 12, 2 times 6, 3 times 4, and I'm done. Okay, which one has all of those? Well, of course, C doesn't. Oops, it's missing which one here? 1, 2, 3, 4, and 6. It's missing the 12. Bad answer. Oh, 0. We know that 0 times 12 is what, class? 0. Bad answer. A is my answer. Okay. What is the least common factor of any pair of numbers? Use the unit vocabulary in your explanation. Okay, well, least common factor. A factor are those numbers that when multiplied give you that number, right? Okay, well, the smallest of those numbers, always when I list my factors, going back up here, here's all my factors for 12. What's the smallest of that? Right, it's 1. Is it always 1? Yeah, it is. It will, I guess is a better way. It will always be 1. Number 1 is, we call this relatively prime. Let me ask you this. If I'm trying to solve a problem, do we usually ever really want to know about one of something? Not really. It kind of seems silly, doesn't it? It's like saying to me, hey, I bought a pack of bubble gum. There's 12 pieces of bubble gum in the pack. How many ways can I split it up? Well, you can give me the whole pack with 12 pieces in it. So usually I don't bother with the one. So least common factor is kind of a silly question to ask. So I really wouldn't ever want to discover what the least common factor is. Okay. Number 18. Marcy has 45 pencils and 20 caps of erasers to use for back-to-school package that will be distributed to the students. She wants each package to include the same number of pencils and erasers. What is the greatest number of packages Marcy can make with no pencils and erasers left over? Explain your answer. Well, to find this, am I going to have more than 20 caps? Like, should I list multiples, like 40, 60? No, we're going to take what we have. We're going to take the 45 and 20, and we're going to split it up. And when I think of the word split, I think of division. And I think of the factors, okay? So I'm going to list all the factors for 45. 1 times 45, 3 times 15, and 5 times 9. What about 20? Am I even focused on the right thing? There we go. This is challenging. 1 times 20, 2 times 10, and 4 times 5. Well, what do you notice is a number that they both share? Of course, 1. But notice the 5, okay? So we're saying we're going to have what? 5, and I'm going to just put it here. 5 packages, okay? And you're going to notice that the 45 are the pencils, so the 5 goes with the 9. So each package is going to have 9 pencils and with 4 erasers. The factors go together. Okay? Next one. Okay? James is buying hot dogs for a party. The hot dogs come in packages of 8 buns. Oh, sorry, 8s. The buns are sold in packages of 6. I'm sorry, I read that kind of fast and didn't pay attention. So the hot dogs come in 8 and the buns come as 6. What is the least number of hot dogs and buns James can buy to have an equal number of each? Well, let me ask you a question. I have students who start listing the factors, 1, 2, 4, and 8. Be careful. What you're telling me about that is when I go to the store and I look at the hot dogs and on the shelf, if I only want 2 or 4, you're telling me that I can go ahead right there in the store and start slicing that package of hot dogs, and I'm just going to shove 2 hot dogs in my pocket. I don't know. That's ridiculous. It's kind of gross to think about if people touched all of our food like that. When things are sold in a package like that, we really can't break it apart. So kind of keep that in mind when you solve these problems. What we're going to have to do is we're going to have to buy more packages until we have the same amount of hot dogs and it matches up with the number of buns that we need. So I'm going to list my multiples. So I'm going to list 8, 16, 24, 32, 40, 48, and then after that's 56, 64. Well, I don't know how far I need to go. I can always come back and add on. So let me just start with the 6 and see if I match up anywhere. 12, 18, 24. Look, I could have stopped a long time ago, couldn't I? So how many? Notice that's how many buns and that's how many hot dogs I'm going to have. But the question really says how many packages. So this is my hot dogs. So how many packages of hot dogs? Well, notice I have 1 package, 2 package, 3. 3 packages of hot dogs. Remember that's 3 packages, not just 3 hot dogs. I'd better write that down. I wrote it small, but. And then 1, 2, 3, 4. So 4 packages of buns. Well, you know what? Doesn't that make sense? the buns come in a smaller amount in a package, so I'm going to need more of them to create the same amount. So that makes a lot of sense to me. Okay, last question of the homework. What is your number? Oh, I'm bad with puzzles. Let's see if I can get this one right. Okay, clue number 1. If you divide my number by 5, the remainder is 4. Okay, so like 14, that would be an example. If I divide 14 by 5, then I can divide it like this. Oops, I'm going to have to hold this piece of paper. Hang on, guys. Okay, so notice here, if I divide 14 by 5, I get 2, but I have a remainder of 4. That's a pathetic 4, but it's a 4. Okay? So that's one way I'm going to think about that. The clue number 2 is my number has 2 digits and both are even. Well, guess what? Do I have 2 digits here? I do, but is one even? Oops, nope. So we know 14 isn't right. Let me pick 24. Okay, I divide that by 5. And you get 20, remainder of 4. So that could work, and 2 and 4 are both even. If you add the digits together, the sum is 10. If I add 2 and 4 together, do I get 10? Nope, it's 6. So I'm going to go looking for some combinations that create 10. Well, if I had 2 and... I know that I want it to end in a 4. So 3 and 4... gives me 7. 4 and 4 gives me 8. 5 and 4 gives me, 5 and 4 gives me 9. So let's try 64. If I add those together, of course I get 10, and I divide it by 5. 1, 5, 1, 4, 2, 10. Did I get a remainder of 4? Yes. Does this number have 2 digits and they're both even? 6 and 4 are both even? Yes. I guess I wasn't even thinking. I could have skipped 54 and 34 because 5 and 3 in those numbers are not even. So I wasn't paying attention. Okay, so what's my answer here? What is my number? It should be 64. Okay. I think I'm done with homework. Hopefully when I upload this, 90% of it will be focused. I'm praying because ultimately I shook most of the time and I wiggled. And so hopefully you can see what we did. Hopefully this will help everyone. If not, please again ask me questions in class. Thanks. Bye.